Welcome back, team. In this video, we'll cover everything that we need to know for week 6 of distance learning. We'll talk about scientific notation, converting back and forth between scientific notation, multiplying, dividing, adding, and subtracting. It's all here. Let's get started. All right, so in our first example that you can use for Monday's practice, we'll cover how to convert numbers that are written as very large numbers or very small numbers and write them in scientific notation. We'll also talk about examples where you can go backwards from scientific notation to the very large or very small numbers. So, with this first example, you have the number 34,050,000. And so when we want to take a very large number or a small number, we want to express these numbers as a product of a number between 1 and 10 multiplied by a power of 10. That's really what scientific notation is. It's expressing a really large number and a really small number in a different way. And so what this is we're going to take our decimal point and we're going to see if we can place it between two numbers that will be between 1 and 10. So if I place that number here, that's still a very large number. So I'm going to keep on placing that decimal, moving it over until I can find a place there where it is between two numbers that are greater than 1 or equal to 1, but less than 10. So I've got, let's see, 1, 2, 3, 4, 5, 6, 7. I had to move that decimal 7 places in order to get a number that is equal to or greater than 1, but less than 10. And 3 and 4/10, that's less than 10. And how many times did I have to move that again? 7 times. So that 7 becomes the power of 10 that I would move. So it's going from really small number here, it's going to go back to this very large number here by multiplying by a power of 10. And I could do the same thing with a small number like this. Very, very small number. I'm not even going to try to read that decimal because it's such a small number. But I know if I move that decimal 1, 2, 3, 4, 5, 6, 7, once again, 7 spaces in this case, I would get 2 and 6/10. Now this time, because I'm going from a very small number to 2.6, in order for this 2.6 to get back to this very small number, I'd actually have to multiply it by 10 to the power of -7. And if you need to, you can review those exponent rules with a negative exponent in last week's video. Now, using what we know about exponents, we could also take a number that's written in scientific notation and turn it back into a very large or a very small number. So since this is a positive exponent, I'm going to take that number 5 and 6/10 and I'm going to move it how many decimal places? Right, based on the exponent, I would move it 9. So I'd move it 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's see, that's a 0 here. All the way, let's see, it's 1, 2, 3, 4, 5, 6, 7. Let's make this a little smaller so we don't get confused. 1, 2, 3, 4, 5, 6, 7, 8, 9. That would be the place of our new decimal. So our new number would have 1, 2, 3, 4, 5, 6, 7, 8 zeros. I'm going to write that down here. 4, 5, 6, 7, 8. And place our commas where they go. 5,600,000,000 would be our new answer in standard form. This is scientific notation. This is standard form. Now, what about when we have a number that has a negative exponent like this? I'll rewrite it down here. 5 6/10 times 10 to the power of negative 5. So as we saw in our last example, that negative exponent tells me that this number is going to be actually smaller. So if I wanted to, I can write down 5 6/10 here, and instead of moving that decimal forward, I'd move it back 5 spaces. 1, let's do it this way, 2, 3, 4, 5. So my new number would now be 0.00056. There we have it, converting numbers from scientific notation to standard form. All right, team, so for Tuesday's practice, you're going to be multiplying and dividing with scientific notation. Now, this might look intimidating, but if you recall last week's work with exponents and the properties of exponents when you multiply and divide, remember that since we have the same base when we're multiplying, what's our rule? That's right, you can just add the exponents. So here, all we're going to do is take our like terms like we did with algebra and put some things together so that it would be easier to get through this problem. So we have 2 2/10 times 1 2/10. That's on one side. These are two like terms. And then we have 10 to the power of 3 times 10 to the power of 5. So really, you get the product of these like terms and the product of these like terms, and then you have your final answer. So 2 2/10 times 1 2/10. Right, it would be 2 6400ths. Let's put that off to the side. And then we have 10 to the power of 3 times 10 to the power of 5. Now remember, since we're just adding the exponents, it's the same as saying 10 to the power of 3 plus 5. So really, our final answer should be 2 6400ths times 10 to the power of 8. When we have a division problem, we're going to divide our like terms and apply those same rules that we talked about last week with exponents. And in this case, since we're dividing, what's that rule? Right, if we have the same base, we can just subtract the exponents. We'll get to that in just a second. So first, let's deal with 8 2/10 divided by 2. 8 2/10 divided by 2 will give us 4 1/10. And then we have 10 to the power of negative 2 divided by 10 to the power of 5. And we know that based on our exponents rules from last week, that's really just 10 to the power of negative 2 minus 5. What's negative 2 minus 5? Yes, it's negative 7. So really, our answer is going to be 4 1/10 times 10 to the power of negative 7. So once we get to Wednesday's work, you're going to get to add and subtract within scientific notation. And when you're adding and subtracting, there's an additional step here that requires you to make sure that these powers of 10 are like terms. What that means is that since you have 10 to the power of 3 and 10 to the power of 5, you've got to choose one of those so that it looks like the other. And in our case here, just for the sake of our example, we're going to make this 10 to the power of 5 so that this matches this side of our problem. So here's 10 to the power of 5. And in order to make this equivalent, I need to move this decimal 3 1/10, 2 spaces over. So 1, 2, that would be 0 31 thousandths. Now I can add 31 thousandths and 3 and 38 hundredths. I get 3 and 411 thousandths times 10 to the power of 5. Similarly, when we're subtracting, we have two powers of 10 that are not like terms. We need to get one so that it looks like a like term, so that it is a like term rather. And in this example, I'll choose the one that's here. I'm going to make this 10 to the power of -3. And since this is greater, -3 is one number greater than -4, I'm going to move this one decimal place over to the left. So this would be 26 hundredths times 10 to the power of -3. Then I'm taking away from 4 and 5 tenths times 10 to the power of -3. Just as I did before, I'm just going to focus my attention on the like terms, 4 and 5 tenths minus 26 hundredths. That's going to get me 4 and 24 hundredths times 10 to the -3, and that would be my final answer. Thursday's work is slightly more challenging in that we have a list of things that you've got to prepare for, because on Thursday, you're going to get to put all of the things that we practice on Monday, Tuesday, and Wednesday in practice within word problems. And so I've got a list of 6 things that you can do to make sure you're solving those word problems correctly. The first, of course, read and annotate. Especially if you're like me, you need to have the printout in front of you. You can definitely be annotating and making notes to yourself to see, what is this question asking me to do? What do I already know that I can use to solve that problem? Again, you know I'm going to ask you, how are you making sense of the problem? Don't just start solving it, but step back, read it, make sense of the problem first, and then read it again to make sure that you understand exactly what you're being asked to do. Once you have an idea of what it is that you have to do, select a strategy. Are you going to multiply? Are you going to divide? Are you going to add? Are you going to subtract? Choose that strategy and start solving. Use the different skills or strategies that we've used last week and this week to help you solve those word problems, and then go back and check your work. See if your answer makes sense. See if you've written it in the right form, that you're multiplying by a power of 10. And that's why the last step here says to check your labels. Make sure that you're writing everything in the way that you should be for scientific notation. All right, team, so that's going to do it for our week 6 video. Remember that if you have any comments, questions, concerns, drop a comment in Google Classroom, and remember to respond to one another's comments on Google Classroom as well. Thanks so much for watching. Stay safe, wash your hands, and show your work.